now we're going to learn this diagram together. The best way to do so is to learn how to draw it yourself. So get out an extra piece of paper and draw the diagram with me. Now, as we said, the most proximal part is the intrahepatic biliary radicals. We're not going to draw them because those are the tiny little ducts that form the portal triads. We're going to start out where they drain into, which is the right and left hepatic ducts. So here we have our right and left hepatic ducts. They're going to converge and drain into the common hepatic duct. Now at this point, all of our hepatic ducts are still intrahepatic. At some point, the CHD becomes extrahepatic as it connects to the cystic duct. Now the cystic duct is what connects the gallbladder to the rest of the biliary tree. So we have our cystic duct here, and then we have our gallbladder. Now what makes the cystic duct special is that it's the only one that has valves, the spiral valves of Heister. The fact that the cystic duct has valves really is quite logical. Remember, the gallbladder's job is to store and concentrate the bile. So we want the bile to stay in the gallbladder until it's needed. So only when the duodenum releases the cholecystokinin, then the gallbladder will contract, squeezing the walls of the gallbladder and ejecting the bile through the cystic duct and through those valves. From the cystic duct, the bile will then flow into the CBD. The CBD travels distally to join up with the main pancreatic duct. And this area where they meet together is called the ampulla of Vater. Think of it like a funnel or a cone where the enzymes can mix together. Then we have the sphincter of Oddi. Its job is to control the flow of the enzymes into the duodenum. So now we have our diagram, and we also understand our flow of bile. The next thing we want to have clear in mind is how we would describe the proximal duct, the distal duct, as well as using the terms origination and termination. So the proximal part of the duct, like we said, is where it's coming from. That also means that would be its origination point. Let's use some examples. The proximal CHD, or the origination of the CHD, is at the convergence of the right and left hepatic duct. So at this point, the CHD starts. The distal CHD, or we could also say the termination, is here at the cystic duct. The proximal CBD, or the origination of the CBD, is also the cystic duct. And the distal CBD, or its termination point, would be when it meets up with the main pancreatic duct at the ampulla of Vater. So you'll notice in this diagram I drew a little dip between the CHD and the CBD. The reason why I drew it that way is so that you can keep in mind that the cystic duct is the point of separation. The CHD does not go directly to the CBD. It ends at the cystic, and the CBD begins at the cystic. So that cystic duct is the point of division between the common hepatic duct and the common bile duct. Learning this diagram in and out, and even knowing how to draw it, is really going to be essential for you to understand the obstructive disease findings. If you recall in our introduction to abdominal pathology, we said that in obstructive disease, the sonographic findings have a pattern, that we will have dilated tubes or ducts above or proximal to the level of the blockage. So in other words, wherever the problem is, wherever the blockage is, everything above it or proximal to it will be backed up and will be dilated. So for example, if we have a distal CBD obstruction, the CBD will dilate first and then eventually everything above it. If we have a cystic duct obstruction, the common hepatic duct and then eventually everything above it will dilate. But if the cystic duct is obstructed, can the CBD dilate? No, because that's after or distal the cystic duct. So that's going to be a common pattern, and a very important tool that you're going to use in your following video is understanding the concept of this flow of bile and the normal anatomy to understand what things will be dilated in the presence of obstructive disease. So learn this diagram well, and you can always refer back to this page in your future lessons.